All right. Well, thanks for being here, everybody. I'm going to talk about a couple of my favorite organisms today, blue jays and oak trees. All right. So oak trees. There's something about that word oak, those three letters, that it kind of brings to mind these kind of like solid, powerful, sort of dark, mysterious powers, doesn't it? Oh, when you think of oak, like a mighty oak. And, I think that's true. And really, when it comes to the ecosystem that they support, it really does ring true. So oaks are the foundation of these really interconnected, elaborate ecosystems in a number of different ways. So first, their leaves, just the oak leaves themselves, support way more caterpillars, so that's butterfly and moth species, than most trees do, over 500 caterpillar species. And those caterpillars and all the other arthropods that are supported on those oak trees feed a lot of songbirds and other organisms at higher trophic levels. So pictured here is a cerulean warbler, which really has a close association with white oak trees in particular, and all sorts of other migratory songbirds that migrate to the tropics and back every year really rely on the Lepidoptera supported by oaks. And then, of course, everybody knows oaks for the acorns. So the acorns themselves, those are the seeds of the oak tree, they support well over 90 wildlife species in North America. Some of these are common prey species for both human hunters and also natural predators. So we have turkeys, ducks, deer, a lot of other mammals and birds and other species that feed and rely on acorns for food. So oaks are really kind of the foundation for a big, elaborate food web, and we're going to look at that a little more. So one of the things about acorns, which I'm going to be talking mostly about today, is... Sorry, can everybody hear me in the back? I didn't check that first. Okay, good. So one really cool thing about acorn production is that they have these what's called mast or masting cycles. So here, mast is another word for seeds or seed production. And what this means is that instead of just producing, a normal amount of seeds every year, they go through these cycles where some years they produce a huge overabundance of seeds, and then other years they produce very few at all. And this is really cool because it's spatially synchronized. So it's not just one tree doing this, it's all the trees, or most all the trees across hundreds of miles, that have this spatial synchrony in how they produce their acorns. So if you look at this figure here, sorry to make your brains work a little bit. So we have the sort of basically abundance of acorns on the y-axis, and then just years over here. So we're looking at 2005 to the present, and this is all of the trees that the Ohio Division of Wildlife surveys every fall for acorns. And if we look at the red line here, so this is just red oak acorns. Some years we have really high, well above average acorn abundance, and other years we have really low average and below average. And so we don't really have that many years that have average acorn abundance. So because they have these big spatially synchronized fluctuating cycles, that really influences a lot of the population dynamics of animals that feed on those acorns. So this is called in another way a pulsed resource, where you have this like pulse of resources. So can anybody think of what's another pulsed resource that exists that we just experienced this year, or a lot of areas experienced this year? Yeah, cicadas, right? So the periodic cicadas, once every 17 years, we had one this year, and it was very exciting. We didn't really have that many at our house, but we went up to Dublin, and Dublin had a ton of them, and it was awesome. They're just everywhere, all the trees, just hitting people in the face. So cicadas are another great example of this kind of pulse resource sort of situation where it's driving a lot of population dynamics. So think of all the nutrients and food that 1 year of all those cicadas all at once is bringing to the ecosystem. And so many birds and other animals are eating those, and it also goes into the soil. So acorns kind of think like that. We're looking at a pulsed resource here. All right, so does this come through? Can you see? I guess you can see it all right. So we're going to talk a little bit about the cascading effects of these mast or seed production or acorn cycles. So on the left here, we have an example of a mast failure year. So we have very low acorn production. And then on the right, we have a high mast year. And so there's some relationships that I want to point out here. So basically, this is one study that kind of looks at some relationships. There's obviously many, many others that happen with acorn production since so many animals feed on acorns. So here we have a low acorn year. Mice, especially white-footed mice and some other rodents, and also deer, they eat a lot of acorns. They really rely on acorns. And so if we have a low acorn abundance here, those mice and deer populations are really going to go down. Not as many mice will survive. They won't be able to support as many young. And then ticks, in particular black-legged or deer ticks, they really rely on these white-footed mice as their kind of main food source for their first blood meal. And so in a year when we have very low mouse production because of low acorns, we also have low ticks. And then that in turn leads to low occurrence of Lyme disease the following year. So there, probably some of you have heard of this relationship before. There's a really great talk on the Ecology on Tap YouTube page about Lyme disease. So I encourage you to check that out because I just watched it. It was very good. All right, but there are also good things that happen in a low acorn year. So basically, here we have mice and other rodents. They are one of the main predators of songbirds, especially ground nesting and shrub nesting songbirds. So when their population is down, that allows some songbirds to increase their population because they're able to raise more young. There's not as much predation. So that's good for the birds. But it's also good for gypsy moths, for example, because white-footed mouse are one of the main predators of gypsy moth larvae. So we have all these interacting factors. So gypsy moths have a kind of nice, good year after a low acorn year because there's not as many predators of their larvae. And then, of course, the reverse is true in a high mast year. So basically, it's good for mice, good for deer, also good for ticks and Lyme disease, but not quite as good for birds and moths the following year. And so there's these kind of year time lag things that happen a lot too. So before I move on, can anybody think of any other? So this is just like the first one or two levels of some of these interactions that can happen. Can anybody think of other interactions or consequences that might result from some of these population dynamics? Got to make you use your brains a little bit, hopefully.
Squirrels.
Squirrels. Okay, yeah. So squirrels.
So many squirrels.
What did you say, Phil?
Car accidents.
Car accidents.
Deer.
Oh, deer. Okay, yeah. Good. Okay. It's like took me a second. Yeah. When you have more deer, they're going to cause more accidents. Also, like more Lyme disease is going to cause more hospital visits, maybe. Squirrel population. I'm going to get to squirrels in a second, so wait for that. But yeah, so a couple other things. All right, so gypsy moths, when they have a big, a good year for gypsy moths, that also leads to a lot of defoliation. In particular of oaks, but also lots of other trees. So that defoliation is in turn going to make it a lot harder for those trees to produce seeds the next year. So we have kind of a feedback loop here where, gypsy moth outbreaks might delay a good seed production year because of this heavy defoliation. So we have another level there. And then also, of course, predators, or some of the higher predators that feed on the prey species like deer, like songbirds, they're going to be impacted by this as well. So, in this case, we might have a Cooper's or a sharp-shinned hawk, which feeds mostly on songbirds. They're going to be impacted by the population dynamics of the songbirds. And then owls and other predators which feed on mice are obviously going to kind of mirror these fluctuations to some degree. All right. So we've established that oaks kind of are this basis of, kind of complex. I've only touched the surface here, but food web and cascade and trophic interactions, and a lot of wildlife feed on acorns. But why produce acorns? Like, what's in it for the tree? So it's great for the wildlife. We have a really nutritious food source. It's high in energy and fat. Acorns are awesome for so many animals to eat, and that's great for the animals. But what's in it for the tree? Anybody? What? Yeah. All right. So reproduction. Basically, they need to disperse those seeds, right? Now, seed dispersal for oaks and acorns is not all of those animals are doing that. So basically, there's only a few animals that are actually dispersing acorns. So really the whole point for oaks to produce all these acorns, they're really just trying to attract a few animals. It just so happens that since they're making a really nutritious food source, it's good for lots of animals, but really they're only trying to, for the self-interest of the oak, they're only trying to attract animals that cache their acorns. So that's the key thing here. So most of these animals that eat acorns don't cache them. They just eat them. And that's not good for the acorn. That's basically like killing the acorn. So that's not a seed that can grow. So here we have what I'll call seed dispersal mutualism. And the most kind of well-known animal that does this caching behavior is a squirrel. So you've probably all seen squirrels, in the fall. They take their acorns, they bring them out to the yard, they kind of bury them a little bit, put some leaves on top of them, do that little thing with their hands, and they move them around a lot. So if you haven't seen that, you've maybe seen the Ice Age movies, the famous squirrel that's kind of, chasing the acorn all over the glaciers. Squirrels do this. So squirrels are one of these seed dispersal mechanisms. And basically how this works is a squirrel will encounter a seed. If they eat it, too bad for the oak, that's a seed that's gone. But they might decide to cache it for later consumption. If they do that, say the squirrel dies or it forgets where that cache is, and so that seed, then that acorn is in a good position to then germinate and grow into a tree. And it's further from the parent tree, so it's been kind of dispersed some distance away. So basically that's the mutualism here. So the squirrels get a reliable food source for the winter because they're coming out throughout the winter to their caches to feed on those acorns, and the tree gets a valuable dispersal service from the animal. But it turns out that, as you might have guessed from the title of my talk, blue jays are actually better seed dispersers for acorns, for a lot of acorns anyway, than squirrels. Why might this be? What's like the main thing that blue jays have the squirrels don't that might help them in this?
Flying.
Yeah, they can fly. Birds can fly, or most birds can fly. All right, so blue jays can fly, so they can easily cover much longer distances, and so this is really crucial. All right, so let's take a look at this real quick. Don't worry if you can't see this, it doesn't really matter, but basically we're showing a map here from 12,000 years ago to 2,000 years ago, and we're looking at the fossil pollen record of oaks, beeches, and chestnuts, and we're seeing how that migrates north as the glaciers are in hatch here, they kind of recede over time, and the fossil pollen record kind of moves north. So basically, blue jays are really the only organism that can explain this rapid dispersal of oaks and beeches in particular following the retreat of the last ice age. So basically, in the last ice age, from the fossil pollen record, we see oak migration rates of over 300 meters a year. So that's pretty fast for a tree, right? Like a tree can't move. Some of these tree populations are moving over 300 meters a year to spread north after the glaciers receded. And really, blue jays are the only organism that can explain that rapid dispersal and migration rate. So blue jays, they're caching thousands of nuts per year. One bird is caching thousands of nuts per year. They can do much longer dispersal distances than squirrels. So squirrels, we're talking like tens to maybe 100 meters or so at the most. Blue jays, we're talking hundreds to thousands of meters, sometimes regularly over 5 kilometers away from the parent tree, depending on the landscape. And then also blue jays, a lot of squirrels do this as well, but blue jays also cache their nuts in the ground, whereas some birds and squirrels cache their nuts in trees. So that's not a good place for an oak to grow. So blue jays cache their nuts in the ground, and they do all this other stuff that's really great for the oak trees. All right, so the other thing about blue jays that makes them really good at this is that they are scatter hoarders and not larder hoarders, which is a mouthful. So the scatter hoarding basically just means that every time they transport a nut, every time they're going to cache a seed or an acorn, they bring it to a different spot. So every single time they take an acorn from a tree and they fly, 100, 300, 500 meters away with it, they're going to put it in a different spot. So that's thousands of different cache locations per bird per year. So that's a lot of great dispersal service for the oaks. And they can carry that seed across, unsuitable habitat. They can colonize new habitats with those oaks that didn't have oak trees before. And they're putting them in the ground. They kind of put them in, they tap them in a little bit, and then like the squirrels, they cover them up a little bit. So very similar to what squirrels do. So just to kind of point out the difference. So larder hoarders, which are like red squirrels, some woodpeckers, they just have 1 or 2 caches where they bring all their acorns into one place. They guard that spot, and then, that's only like one place that the oak might get a dispersal. And oftentimes, especially for chipmunks and other rodents, these caches are underground, and that's not really a good dispersal service for the oak. All right, so now that we've kind of talked about why blue jays are so good at caching acorns and how oaks are the foundation of these great, mighty ecosystems, I do want to talk a little bit about my research, mainly because I want to show you some cool blue jay videos a little bit later. But all right, so some of my research, I'm looking at how this mutualism between blue jays and oaks, or in general, nut-bearing trees, might shape the future of Appalachian forests. So I'm just going to talk today a little bit about the imminent reintroduction of American chestnut. So American chestnut, I'll just give a brief kind of summary of this story. Probably most people are a little bit familiar with it, but American chestnut was once a canopy dominant species across much of the I just said across like an Ohioan. Weird. I've been living with my wife for too long. All right, so there used to be a canopy dominant species across the Appalachian range, and they, like oaks, supported lots of wildlife species. So chestnut seeds are very similar in size to acorns. They're even easier and to eat and more tasty than most acorns are. So the shells are softer, the meat on the inside is sweeter, so it's easier for more animals to eat them. Also, they don't go through these masting cycles, so chestnuts kind of have a more even production of seeds every year. So that was kind of a buffer against those low acorn years. For animals that really relied on acorns and other nuts, in a very low acorn mass year, they may have kind of relied on the chestnut seed production to survive that winter. Anyhow, so chestnut supported a great ecosystem in the Appalachians. Also, a lot of Appalachian communities relied on them as they kind of sold chestnuts for food and for livestock food. But of course, humans ruin everything we touch. And at some point, about 120 years ago, a introduced fungal infection, an introduced fungus, came into the U.S. In Manhattan, where most things start, and started infecting chestnut trees and basically killing adults. So this infection spread within a couple decades to kill almost all of the mature chestnut trees across their entire range in a few decades. They died off. They still exist today as stump sprouts, but they basically die before they reach maturity. Anyhow, in the last 40 years, there's been an effort to try and breed blight-resistant, so the chestnut blight is the disease, trying to breed blight-resistant hybrids to then put back out onto the landscape. And so we're getting closer to these blight-resistant chestnut trees that may be reintroduced into the Appalachians. So I want to talk a little bit how the role that blue jays might play in that. All right, so the first thing I'm looking at with this is, do blue jays prefer chestnuts over some of the common acorn species that are present? In order to do this, I had 6 platforms spread out to the forest at my field site in Southeast Ohio, and I had cameras on there. And then I had 3 species of nuts, white oak acorns, black oak acorns, and American chestnuts, to see what the blue jays would take. And these cameras are kind of recording the order in which they were moved. All right, so let's look at a video here of some blue jays trying to get some acorns. So here, this blue jay, he already has one in his bill. I think he's trying to get a second acorn in there, but he's not really sure how to do it. He's like hammering it down. But we have a companion shows up here soon who knows what he's doing. Now watch this guy closely. He grabs one, immediately puts it in his crop. So he's holding it. Then he picks up another one, so he actually took 2 acorns there. So blue jays have is called a crop. They have this little throat pouch where they can hold 1 or 2 acorns depending on the size of the acorn. So they can actually transport, 2, 3, or 4 acorns depending on the size of the acorn. So that was one little clip of what I had to look at hours of. Okay. All right, so here's another one. I just want to show this, or maybe you don't know, but blue jays are known among the birding community as being kind of like aggressive, bullies. Yeah, the A word. This is recorded, so I don't want to swear on camera. Yeah, so they're known to be kind of, bullies around the feeders especially. So I just want to give this as an example of they're not always bullies. There are birds that can hold their own against blue jays and maybe even bully them. So just kind of watch this interaction with this is the red-bellied woodpecker and several blue jays that want to feed from the platform. So they're kind of wary of this red-belly just kind of like posted up in the middle of this thing, and he wants to eat the acorn there. He's not taking it away like the blue jays do. He just wants to eat it there. And these other guys are a little wary around him. I'm not really sure. Yeah, he's an ornery little woodpecker. All right, so he kind of like defended the platform while he's up there eating his acorns. All right. The other way that I'm looking at how blue jays might impact chestnut, dispersal efforts is how effective they are at dispersing those chestnuts. So I want to find out where and how far blue jays are going to take the seeds, and when they cache those seeds, are those cache locations actually beneficial for the germination and growth of chestnut trees, or are they just going to die in those locations or something? And so the way I did this was by putting radio transmitters, little small radio transmitters, inside the acorns and chestnut seeds, and then offering those up at those platforms for the birds. And then after they took them, I track from the signal that radio transmitter is giving off. I find the cache site and then plant viable chestnut and acorns at those locations. So I'll just show you what this looks like, because this is also a little interesting. So here I had started off with 9 acorns, or 9 nuts of the 3 species. So this guy, again, he takes a black oak acorn and puts it in his crop. So he's got it back in there. He's not swallowed it. It's just sitting there in the back of his throat. And he's looking at a white oak acorn, doesn't really like it that much. And then he picks up a chestnut. So that's a chestnut seed that he just took and flew off with it and hopefully cached it. He may have eaten it. I'm not sure. All right, one more video, because, who doesn't like watching birds? All right, so here we have the same platform. So they've basically taken, he didn't like that, so that was another white oak acorn. He don't seem to like white oak acorns. So right now, that's the chestnut. He just took the last chestnut. And this guy takes one of the white oak acorns. So I just want to show you, this is how, in case you haven't seen it, this is how they eat acorns. So he grasps it on the sides with his 2 feet, and then he pecks at it until he breaks through the shell, and then he eats out the meat from the inside of the acorn. So he doesn't eat the whole thing. And so when he gets to the transmitter, there's a transmitter on the inside of all these acorns. When he gets to that, he'll just drop it. He knows it's not food. He's not going to swallow the transmitter, in case you were worried. All right. So then, basically, after they take those nuts, I get out my antenna. What did I just do? Okay. I take out the antenna. I track until I find the cache site. Plant acorns and seeds and chestnuts at those cache sites, monitor their growth into seedlings here, and then collect a lot of veg data, which ecologists all know we have to collect a lot of veg data. So basically, just to kind of, the point of this part of the study was to see how well blue jays might disperse chestnuts, and to really inform chestnut restoration efforts, and kind of find out where they might be able to locate founder populations that would increase the effectiveness of blue jay dispersal. All right, so just to bring it all back together, kind of what we talked about, oak trees are indeed the foundation of a great community of interacting species and factors, but this really couldn't be possible without these blue jays doing the heavy lifting of these acorns every year and bringing these oak trees into new areas, new locations, and hopefully chestnut trees too when that happens. And so really we should kind of thank the blue jays for all this hard work that they've done. And next time you see a majestic blue jay, just thank him for all that hard work he's done. In particular, if you see him carrying an acorn, so now it's the beginning of the fall, it's the beginning of caching season. The acorns are starting to ripen. So kind of keep your eyes peeled. You might see one flying with an acorn. You might even be lucky enough to see a cache. And so, yeah, hopefully you respect blue jays now. All right, we got some questions.